Hello, water managers and SWMS users. I'm Russell Errett out of the Water Management Systems Division at the Hydrologic Engineering Center, and I'm going to be covering SWMS real-time modeling. And so this is going to be a multi-part video series. So this is the first part. We're going to be covering how to build a CAVI watershed and prepare it for real-time forecasting. And then in this part, we're going to go over an overview of how to build a CAVI watershed for development for real-time modeling. And then in subsequent videos, we're going to go through SWMS real-time modeling, how to create a forecast, time windows, how to create that forecast, how to view reports, results, and then go through saving the models and results for usage outside of the CAVI itself. So for this entire presentation, we're going to be going back and forth between the Setup tab and the Modeling tab within the CAVI. So for this first part, we're going to be in the Setup tab for the development and integration of the modeling to get it set up to be used within the Modeling tab itself. So before we can do any of this, we need to define a watershed location. So this would be the first thing. Even if you had a developed SWMS watershed and you wanted to use it just to create forecast, you still need to define a watershed location. This is the first time you've opened the CAVI and you've not ever defined a watershed, you'll probably get a pop-up that says, hey, you don't have any watersheds defined or watershed locations defined. Would you like to define them now? And you can click yes, and it'll get you to the same similar menu I'm going to talk about. If you've closed that or you have a new location that you want to define as a watershed location, to get to that menu option, you go to, before you open up any watershed, you did go to the Tools and you go to Options. And then from the Options menu, there's a lot of tabs here, but there's a Models Directories or Model Directories tab. And this is where you would define your watershed directory. Now, you can have multiple watershed locations. You give it a name and then you give it a location. And so for this example, there are 6 locations. And there could be a reason why you would have only one, or you'd have several. So maybe you only operate watersheds for water management operations, and that's all you do. So maybe everything sits in one folder, so you may only have one location. For this example, it might be MVS watersheds, and here's the location, and that's it. If you are responsible for doing development and maintaining those watersheds, you might have a location for your operational watersheds, and maybe you have a location for where you do your development. And if you do development for watersheds outside your office or do testing for that, you might have watershed locations for other projects that you're doing for other offices or for the MMC, and maybe you are also testing different versions of the software. So you might have a version for the software that you're currently on and the next software you're going to. So there's a reason you could have multiple different locations. So don't be scared if you only have one location or 0, or if you have 10. You can have as many as you really want to. You can always go back and add locations later on. You can remove them after you've decided, okay, I don't no longer need this watershed that I've been doing development on, or I moved it somewhere else. You can remove it, or you can edit location. Like, I want to move this somewhere else, and you can edit that location and redefine it. One of the things that I've noticed as a common error, when you define where your CAVI watersheds reside, you typically are going to go to some location. So for example, here it's on my C drive, WC. This is the old school for St. Louis's water control. And then there's a folder in there, it's called SWMS Watersheds. Underneath of that, the CAVI will create a database, a forecast, and a watershed folder, even before you create a new watershed. So even if you don't have any, these 3 folders are created. If you're putting watersheds on your computer and there are already defined watersheds that are developed, these 3 folders may exist. When you're defining where those watersheds are, make sure you're giving it that parent folder that these 3 folders are underneath of. So you want to go to the SWMS watershed folder. So if you're over here, C, WC, SWMS watersheds, this is the location you want to define as that watershed location. The CAVI is smart enough to know what database is, what forecast folder is, and what watershed folder is. And we will discuss what those are for and what they're used for and how the CAVI navigates between those. But make sure you're not navigating too far down into this folder and defining this as your location of your watersheds, because you're now starting to get into a nested environment, and that's too far into the folder structure for where your watersheds are located. Common error. So I've just noticed when people try to open watersheds, nothing shows up. That's the first diagnostic thing I do. I'm like, are you sure you've defined your watershed location correctly? So just something for you to know. If you're seeing 0 show up and you should be seeing 5 or 10 watersheds, that could be one reason why. So let's talk about the CABI modeling setup. Like, how do we set up the models themselves before we can start doing the forecasting? So this is a good reference slide. This will tell you the steps to go through when you're creating a new watershed. I'm going to go through each one of these kind of detailed in the subsequent slides from here. But if you ever get lost along the way and you're like on step, I don't know, 4 or something, so you're kind of along the way, there is on the setup tab, if you go to the models menu, go to next steps, this dialog will pop up. It won't tell you where you're at with it, but it'll give you the steps that are in the slide. And so you might say, I just got done with doing my forecast run setup. What's next? Oh, model linking. That's the next thing. And then I need to do my extract list, right? So it'll let you know the step-by-step process you need to go through. It might be worthwhile to maybe print this slide out or print this thing out and start just crossing off as you go through it so you know where you're at in the process, because there's a lot of steps to go through it. And each of these steps can take some time. And so you might get a little lost in where you're at. And then also, sometimes you might have to go backwards and redo some of these steps or add to these steps. So just know where you're at in these steps as you go through it. So let's go through each one of these steps through these subsequent slides. So let's define a new CABI watershed. So if you don't have a watershed built yet and you're creating it from scratch, you would go from the setup tab, go to File, New Watershed, and this dialog would pop up. And so from here, you would give it a watershed name. Make sure you come up with a good watershed name, because you can't change this once you create it and move on. So if you want to change the watershed name, you're probably just going to have to start over from scratch and re-import these models and do that over again. So make sure whatever watershed name you give it, it's a good one. Don't give it like Utopia River Test or Trial, because that's going to be its name forever. So just go ahead and just give it the proper name you need to give it to and move on with that. Give it a description. It's not required, but I strongly recommend putting a description in there. Hey, this watershed was built in 2025, and these are the models that were handed to us from the MMC in 2019, and they were upgraded in 2024. Whatever. Put all the descriptions you can into it, because this is something that everyone can get to. It might be a lot easier to find this description in here than it could be the report. Add the location where the report resides for it. Tell them, hey, here's a description of this, and also if you have access to our share drive, here's the location of the report. And so put all the descriptions in there as best as you can. You can always go back and add to this description. This is an editable thing after the fact, unlike the watershed name. Watershed location, we just covered that, so hopefully you have defined that. If you have not, there's 3 ellipses over here that you can define where that watershed location should reside. So this will be where it's going to get saved. And the folder structure I was discussing, it will save this watershed you're creating underneath of the watershed folder. Define the unit system. Generally in the US we're using English, but you can also use SI. Add a map layer. I recommend only adding 1 map layer. You can add more than 1, but I generally only add 1. And generally it's mostly my stream centerline that I'm adding to it. But most importantly, whatever shapefile you're adding for this, it's going to set your coordinate system here. And in the CONUS, the lower 48, the standard we have at the MMC or that we recommend is using the Albers equal area. So hopefully you have your shapefile that has the Albers equal area projection. But if you're also building a project and it has a different standard that needs to be used, make sure that the map layer you're using has the projection that you're trying to set the watershed in. Also the server. So we're currently still in a transition between our T7 server databases, and we're migrating towards the cloud. So currently you might be on your T7, so define that server location. But also if you're building new watersheds that are going to be plugged into the cloud, you might have a CDA instance or whatever you're going to define that name as. This is where you would either go in and set up that login server setup or have it already defined and you're just selecting from the drop-down menu. Again, this can be changed later on. And you can also add map layers after you're done with this. So once you add this 1 map layer, it doesn't mean you only get that 1 map layer. You can add these later on. This just helps set up that projection. And then time zone. Once you set this is very difficult to change. So try to make sure you get your time zone set correctly. I am used to using UTC because the precip grids I get, the data that's stored in the database that I'm familiar with are all in UTC. So I always generally set up my watersheds to be in that same time zone, and I just do the conversions to local time zone and different viewing ways of looking at the plots. But you can set them up at local time if you want to. If you want to have it Central Time, Eastern Time, you can set those up as well. So define all of this up front, and then when you click OK, it'll create a watershed, and you'll start to go to the next steps. And you should have a watershed that's probably blank that just has some things in the background. And then once you do that, then we're going to start digging into building the setup. So if you look over here, this is the modeling tree over here. So this is going to be where we start to import models, and you're going to start to see the modeling tree. This is kind of what a full-fledged CABI setup looks like. We have models in the modeling tree. So we have multiple METView, we have multiple HMS. Soon MFP will be gone. We have ResSim, FIA, multiple RAS projects here, stream alignment, and then we have all of our different forecast run alternatives that are down here. So this is what it would look like when you're done. So kind of working on the next step, we are going to work in on importing models. So the next step, once we set like a program order, we'll come back to that. We're going to import models. So we're going to import, and it doesn't really matter, except if you have a ResSim model, it is recommended to import the ResSim model first. The reason for that is because ResSim has a stream alignment that is compatible with the CABI. So you either need to import a stream alignment in the CABI first and then import the models, or what I recommend is go ahead and pull in your ResSim model, because this is a stream alignment that will get imported into the CABI, and that stream alignment is used to render all the other models within your watershed. So I recommend doing the ResSim import first, and then going through your METView, HMS, FIA, or RAS, and then FIA. Once you have your models imported, you're now going to set up a program order. And so the default program order hopefully is METView to HMS, ResSim to RAS, FIA. There is a reason you might have different program orders. Maybe you have multiple HMS models that might have to be run before it goes on the ResSim. Maybe there's multiple RAS runs. There are different reasons to have different program orders, but make sure your default program order, if it's not this, it's set correctly. This is kind of telling you what order the models are going to run in by default. And so this is kind of out of the box, and so hopefully you're able to get your model set up this way. And so then the next step is defining model alternative keys. So for each model alternative, individual model run alternative, you're going to give it a key, and it's a single character. It's either a numeric value or a character itself, like a alpha character. And so you cannot repeat the alpha characters or numeric characters in a particular model. So like RAS can, once I define this as M can no longer be used in any other RAS model alternative. Same thing with a number. If I gave it 1, I can't use 1 anymore. You can use this alpha numeric key again for another model alternative. So you could have, say for example, METView could have 0, HMS could have 0, ResSim could have 0, FIA could have 0, RAS could have 0. So you can have 0, 0, 0, 0 all the way through them. They just cannot be reused in this same model itself. So they're very unique to the model itself. I wouldn't overthink this too much. This is really only visible to you as the modeler and the user as the CABI. The end user seeing the results, you can change the legend and what it's viewed. So this is really kind of a detail to the engineer itself that's running this model. Then you're going to create a forecast run. The forecast run is linking together all these model alternatives. So this example is an FDR, so we have 2 RAS runs. So you can see my program order is FDR. So we have METView, HMS, ResSim, 2 RAS runs, 2 separate RAS runs, and then FIA. And you can kind of see the alphanumeric key here, and we're giving it a name. So you can give it a name, whatever name you want to give it to. So you can see several different types of names have been given to each of these forecast run alternatives that are in this list here. So make sure you add a description to each one of them and what they're for. I've given you a bad example because I have FDR. It's not describing what it's for, but it's for flood damage is reduced. Then we go through model linking. And so in the model linking, this is where you're going to link where the information the model is getting its information from or its data from. So for METView, it's going to come from extract. Obviously, you're extracting precip grids for it, but HMS is probably getting its precip information from METView. And then all the other information might come from extract. So this is an example of RAS. RAS is getting information from ResSim for its outflows for the reservoir projects that are in here, and it's getting its local flow from the HMS model. So this is the HMS subbasin stuff. And then there's also some things coming from extract that are dependent upon it. And then you can see there's some observed information that is coming from extract as well. So this is where you define where the pieces that each individual model is going to get its input from, and then that's how the sequence goes through the model linking editor. And then we're going to edit the extract. We're going to create an extract list. And from this top part up here, you can start to create an extract list. I like to create extract lists based upon individual things. So I like to create an extract list specifically for a cumulus extract of observed grids and one for QPF grids. The reason I separate them is if I have to rerun them to get new grids or updated grids, I don't like to rerun all the observed if I'm trying to get an updated QPF or vice versa. I like to limit the amount of what's being extracted in each one of them if I have to rerun them. That's why they're separate. I generally try to create my time series as one, and if I have like river forecasts, those are typically like boundary conditions on the downstream end. I set those up as a separate one as well, things that are isolated so if I don't have to run them all individually. You can break these down even farther. Like you might have time series as flow or time series as elevation or time series for ResSim or time series for HMS. Set them up as you see fit, but these are going to be set up to be the inputs for the models that are looking for extracted data. Also, some of these are observed data for calibration. So you might need flow data even though it's not driving the model. They're used for calibration so you can calibrate the model. So you'll have multiple extracts. Anything highlighted in blue is run by default. So anytime you create a forecast, they're going to run by default. If they're in black, they're ad hoc, which means they're going to be run whenever you tell it to run. So you'll have to go through the menu and tell them to run after the model's created. If you have any questions about our software, need any help, or are looking for additional training, check out these links. They can also be found in the description below. Thanks for your time.